Okay, I just realized right now. It's all right. Okay, so look, y'all, let's do the next one. Again, we'll do it the same way. All right. So the first thing I'm going to do here, y'all, I want to think of everything as a fraction. So I'm going to think of this one as 1 over 1. Okay. Now, in this particular problem, y'all, since my denominators are different, I have a 4, I have a 2, and I have a 1. The way I'm going to find my common denominator, y'all, I'm going to come back over here. And y'all, I'm going to grab my multiplication table. Okay. Y'all, again, I'm a huge fan of calculators, but I'm also a big fan of my multiplication table because my multiplication table, y'all, will help me find my common denominator, hopefully in a very easy breezy cover go away. So look, y'all, if I come back to my problem, the numbers on the bottom are 4, 2, and 1. Okay, so I'm going to look at those numbers on my chart. So here's 4, here's 2, and here's 1. What I'm going to do, y'all, I'm going to go to the right, okay, on those 3 numbers. And I want to find the first number that they all have in common. So look, y'all, here's the number 4, here's the number 4, and here's the number 4. That's the first number they all have in common. So that would be what we call our lowest common denominator, okay? Y'all, they also have the number 8 in common, right? They all have the number 8, but 4 is the smallest one. Typically, y'all, we try to go with the smallest one. And again, I mean, there's no need to keep going down because if the first number I see is 4, 4, and 4, well, hey, there's my common denominator, right? So 4 is my common denominator here, y'all. So what we're going to do now, we're going to come back this way. I'm going to draw a little box here and a little box here. And we're going to write 4, but we're going to write it, y'all, as 4 over 1. Okay. All right. Now, the second thing I'm going to do, y'all, just like we did before, the top numbers multiply to the top numbers. So I'm going to say, what's 4 times 3? That's going to be 12. Y'all, there's an X there, so I'm going to put my X right here. What's 4 times a negative 1? That's a minus 4. And what's 4 times a positive 1? That's a positive 4. Now, I'm going to take this bottom number, and I'm going to multiply it by each of those guys downstairs. So 1 times 4 is 4. 1 times 2 is 2. And 1 times 1 is 1. Okay. Now, again, y'all, if we did this right, all of our fractions, y'all, are going to go away. So look, 12 divided by 4, 3 with an X. Minus 4 divided by 2 is just 2. And then over here, y'all, 4 divided by 1 is still 4. So again, y'all, if I think about my original problem, right? Here was my original problem right here. And let's do this, okay? But if I look at this guy here, and I look at what we now have, yeah, this equation in green hopefully seems to be easier, okay? So y'all, just like we did before, I'm going to draw my line going down. I'm going to add 2 here. I'm going to add 2 there. So that 2 and that 2 are going to cancel out. I'm going to bring down my 3x. 4 plus 2, y'all, is going to give me 6. So again, y'all, if we have 3x equals 6, all we need to do is divide by 3 and coming up with x equals 2. Okay. All right. So, y'all, I'm hoping that as we're going through solving equations with fractions, that it's kind of making some sense and we can see how we can take a problem that maybe doesn't look as pretty like this one and make it into one that's a little bit prettier, like, say, that one there in the green, right? And the process is not too difficult. Y'all, again, my multiplication table, y'all, really, really helps me out a whole lot here, okay? All right. Y'all, I'm going to do the next one. And again, I'm going to go about it the same exact way. Sorry, I'm trying not to sneeze. Y'all, I'm going to think of this guy being over 1, and I'm going to think about this guy being over 1, okay? And so, y'all, I'm going to look at my denominators. I have 4, and I have the number 1. So let's go back to our table. Here's the number 1. And here's a number 4. And if I go to the right, 4, and if I go to the right, 4, that's the first number we have in common. So, y'all, my common denominator is going to be 4 over 1, okay? All right, so look, y'all, we're going to go really slow. I'm going to take this 4, and I'm going to multiply it by that 2. That's going to give me an 8. And then I still have this x plus 1 right next to it, right? Okay. Now, I'm going to take that 4 and I'm going to multiply it by that 3x. So 4 times 3xl is going to give me a 12x minus, because there's a minus right here, and 4 times 2y'all is going to give me an 8. And then remember, we're going to multiply the bottom numbers to y'all. So 1 times 4 is going to give me a 4. 1 times 1 is going to give me a 1. And 1 times 1 again is still going to give me a 1. Okay. Now, again, y'all, if we did this right, our fractions should go away. I want you to notice something here. We have an 8 on the top, and we got a 4 on the bottom. Y'all, 4 goes into 8 2 times. So I got a 2 and an x plus 1 equals, over here, y'all, 12 divided by 1, still 12. 8 divided by 1, still 8. Okay. All right, next step, y'all. I want to multiply this 2 times each of those numbers. So 2 times x is a 2x. 2 times 1 is a positive 2 equals 12x minus 8. Okay. Y'all, I'm going to draw my line going down. Okay. Now, if you remember this from Thursday last week, and again, y'all, we really have options here. One of the things that I had mentioned is if I want to avoid having a negative in front of my x, I'm going to move the smaller x to the bigger x. Y'all, between the 2 and the 12, the 2 is smaller. So let's go ahead and minus 2x on both sides. Okay. Now I have 2 equals 12 minus 2 is 10x minus 8. Okay. So then I need to go plus 8 here, plus 8 here. And that's going to give me 10 equals 10x. And then finally, my last step is to divide. And we get x is equal to 1. Okay. All right. So again, y'all, the process in doing these problems is let's find out what our common denominator is, okay? Excuse me. Let's multiply everything by that denominator. If we do this correctly, y'all, all of our fractions are going to go away, okay? And guys, you can see as we're going through these, the fractions are canceling out. Now, one thing I do want to mention doesn't necessarily mean that my final answer won't have a fraction. Sometimes we'll get a fraction, like sometimes my answer might be 7/5 or something like that. But the equation that I'm working with does not have the fraction, okay? All right, y'all, I'm going to scroll down a little bit further. And let's see if we can do this next one. All right, first thing I'm going to do, y'all, think of this over 1, think of this over 1. And what I'm going to do here, y'all, I'm going to look for my common denominator, okay? So, y'all, I got 1, 6, 1, and 6. Okay, so let's go back to our chart. Here's the number 1. Here's the number 6. Look, y'all, the first number that we have in common to both of them, sorry, trying to get my pen to work here. The first number I have in common to both of them is the number 6. So let's do this. Let's go 6/1, okay? And what I'm going to do here, y'all, is I'm going to go ahead and multiply everything by the number 6. So let's go 1, 6 times x, 6x. 6 times 7, 42. 6 times 2x, 12x. 6 times a minus 7, minus 42. Okay. Y'all, I'm going to start multiplying here. Okay. 1 times 1 is a 1. 1 times 6 is a 6. 1 times 1 is a 1 again. 1 times 6, y'all, one more time is just a 6. Okay. All righty. So, y'all, let's take a look. 6 divide, sorry, I don't want it to look like a negative. Oops, that's not what I meant to do. 6x. Okay. Look, y'all, 6 divided by 1, still 6. 42 divided by 6, 7. 12 divided by 1, still 12. 42 divided by 6, minus 7, right? Okay, again, remember what we said, y'all? We're going to move the smaller x to the bigger x. Let's see. So let's see, guys. We're going to move the smaller x to the bigger x. Y'all, I'm going to go like this. Minus 6x here, minus 6x here. Okay. Those are going to cancel. Y'all, we got a 7 equals 12 minus 6 is a 6x. Okay. Minus 7. Okay. Y'all, I want to go ahead and add 7 to both sides. So those are going to cancel out. That's a 14 equals 6x. So y'all, right here, I'm going to write 14 equals 6x. Remember, the last step here, y'all, is to divide everything by 6. Okay. And then right here, y'all, we can simplify that fraction. We can divide both those numbers by 2, y'all. So that's going to give me 7 over 3. And again, y'all, like I said, it doesn't mean that when we're doing these equations of fractions, the fact that we were able to get rid of the fractions here, right, in this line, doesn't necessarily mean that I'm not going to have fractions in my answer. It just meant that we're not going to, that it doesn't mean we're not going to have fractions in my answer. It just means that we don't have fractions here. Okay. All right. So look, y'all, let's try the next one here. Again, I'm going to scroll down a little bit further, and I'm going to put this over 1, and I'm going to put this over 1. Okay, so let's take a look, y'all. We got 3 different denominators now. We got 2, we got 1, and we got 5. Okay, so let's come back to our chart. We have 1, we have 2, and we have 5. So y'all, I'm going to start scrolling down so I can see what's the first number that I have in my list. So look, y'all, here's 10, here's 10, here's 10. 10 is the first number I have in my list, y'all. So I'm going to come back this way. And again, y'all, I'm going to multiply everything by 10 over 1. I'm going to go 1, 2. Okay, so let's see. 10 times x, that's a 10x. Okay. Minus 10 times 1 is a 10. Okay. 10 times x again, y'all, is a 10x. And 10 times 2 is a 20. Okay. And now I'm going to multiply 1 times 1 times, right? All of them are going to get multiplied by 1. So look, y'all, 1 times 2 is 2. 1 times 1 is 1 times 5 is 5. And 1 times 1 is 1 again. Okay. Y'all, if we did this right, all of our fractions are going to go away. Let's take a look. 10 divided by 2, that's just a 5x. 10 divided by 1, that's just a 10. 10 divided by 5, that's a 2x. And 20 divided by 1, y'all, is a 20. Okay. Y'all, I'm going to go ahead and draw my line going down here. And just like we've been doing before, y'all, I'm going to move the smaller x to the bigger x. So I'm going to get rid of this 2x here by minusing it. Okay. Let's see. 5 minus 2, y'all, 3x minus 10 equals 20. Okay. I'm going to go ahead and add 10 to both sides. So let's see. We got 3x. Those 10s cancel. 20 and 10, y'all, is going to leave me with a 30. I'm going to divide everything here by 3. And we come up with x equals 10. Okay. So, again, y'all, as I'm going through these problems, I'm hoping that they're making sense and that as we go through the process, we're able to see, which of these we can actually, how we can reduce these numbers, right? How we can make these numbers smaller, okay? So look, y'all, we got another one here. Let's try it. Again, I'm going to do the same approach, y'all. I'm going to look at each of my denominators. So the first thing I'm going to do is I'm going to think of this guy over 1. Okay, so look, y'all, we got 4, 1, 2, 12, and 6, okay? So 4, 2, 1, 12, and 6. So look, y'all, if I go 12, let me go to 12, 12, 24, numbers start getting big, okay? But I see there. Okay, let's take a look. 6, boom, I see the number 12. Y'all, that was the first number here. 4, look, I see the number 12. It's right there. 2. Look, y'all, I see the number 12. It's right there. And 1. Boom, I see the number 12. It's over here. Okay, let's see. Good morning, good morning. Glad to have you here with us, Evelyn. I just saw you were with us, so just wanted to say hello. Okay, so y'all, it looks like 12 is our common denominator, okay? So look, y'all, I'm going to go like this. I'm going to go 12 over 1, okay? Y'all, I'm going to go real slow here. So 12 times 3, 36 with the letter X, okay? 12 times a minus 1, minus 12. 12 times the number 1, positive 12, but it has an X there with it too, okay? One more time, y'all. 12 times 5. 12 times 5, y'all, is 60. But we got an X, so let's not forget it. And then 12 times 1 is still 12, okay? Now, remember, y'all, the bottom numbers are getting multiplied by 1. So what that means, y'all, is that my bottom numbers stay the same. Because 1 times 4, that's still 4. 1 times 1, that's still 1. 1 times 2, that's still 2. 1 times 12, that's still 12. And 1 times 6, that's still 6, right? Okay, so let's take a look, see, y'all. We can go ahead and start dividing. 36 divided by 4, 9. 12 divided by 1, 12. 12 divided by 2, 6. Let's see. Over here, y'all, 60 divided by 12, it's actually 5. And 12 divided by 6, that's a 2. Okay. All right. So let's take a look here, y'all. As I'm going through this part here, we're going to combine our like terms. So we got a 9x and a 6x. That's going to give me 15x minus 12 equals 5x plus 2. Y'all, like I said before, we're going to move the smaller x to the bigger x. So let's go ahead and minus that 5x on both sides. Okay, so that's going to give me a 10x minus 12 equals 2. Okay, y'all, I want to go ahead and add 12 to both sides. So we have 10x equals 14. And then finally here, y'all, what we're going to do is we're going to divide everything by 10. And again, at this stage, y'all, all I'm doing is I'm dividing both of those numbers by 2. And that just leaves me with 7 over 5. So we got a 7 over 5 there, y'all. Again, guys, one thing I really want to emphasize here is that in these problems, it's okay to get a fraction as my answer. All we're trying to do is make the process of solving the equation kind of like the problems that we did on Thursday morning, okay? So we're trying to make them easier to solve for, okay? And again, if we get a fraction in our answer, y'all, that's just what we get, okay? All right, so look, y'all, those are the problems with fractions. What we're going to do now is we're going to talk a little bit about word problems, y'all. And in word problems, again, most people are not big fans of word problems, y'all. But what I'm hoping to show you guys this morning is some of the problems, y'all, are going to be a little more challenging than others. But what I'm hoping that we can do is figure out a nice way to kind of do some of these problems that we got here, okay? So let's try this, y'all. The directions here, can we translate this thing and can we solve it? Okay, translating it, y'all, just means how do we go from a sentence to like an equation? Okay, so number one, sum. Y'all, sum means that we are adding. Okay, anytime I see the phrase a number, we're going to call that our x. Okay, so look what it says. Twice a number. Twice a number, y'all, means 2x. Because we're finding the sum, that means that we're going to add this number to it. Okay, so twice a number in 7, the sum of that, is equal to, okay, that means equal to, sum, again, y'all remember, sum still means add, the number, which we call x, and 6, because we're adding, it's x plus 6. All they want me to do now, y'all, find the number. Okay, so let's go like this. Let's move the smaller x to the bigger x. Okay, so 2x, y'all, I can think about that as a 1x. So 2x minus 1x is still just a 1x. Plus 7 equals 6. Okay. Y'all, I'm going to minus 7 on both sides. And then over here, let's take a look and see what we got. 6 minus 7. Remember what that means? That means I have $6 and I owe you 7. So y'all, if I owed you 7 and I only had 6 and I gave you the $6 I had, you'd say, okay, but you still owe me $1, so it's negative 1. Okay. All right. Y'all, the next part here, 3 times a number minus 6 is equal to 2 times a number plus 8. Okay, 3 times a number. So look, y'all, we're going to write 3x, okay, minus 6 is equal to 2 times the number. Remember, the number we just call x plus 8. So y'all, I would definitely say this problem is probably a little bit more straightforward because you're telling me exactly what to write. 3 times the number, right? 3x minus 6, there it is equal to, there's the equal sign. 2 times the number, 2x plus 8, right? Okay, y'all, I'm going to draw my line. I'm going to move the smaller x to the bigger x, right? So 3 minus 2x is just an x. Minus 6 equals 8. Sorry. So right here, y'all, I'm going to go ahead and add 6 to both sides. And 8 plus 6, y'all, should just give me 14, right? And there we go. Okay. Good. Y'all, again, at any point in time, guys, those of you who are online, if you have any questions, please tell me, like, turn on your mic, let me know. I want to make sure that you guys are doing okay here, all right? So there's something that I'm doing that just doesn't make any sense. Just tell me, turn on your mic, and I'm happy to go over it again, okay? Yo, the next part that I have here, these are the actual, I call more of these like word problems because there's kind of like a little story that's kind of going on here, right? So the other ones were just kind of like, hey, 2 times a number minus this. I mean, it's just kind of getting us in the, kind of getting us to figure out how to write stuff out. But like this is actual word problem. So let's take a look. It says a 25-inch piece of steel is cut into 3 pieces. The second piece is twice as long as the first piece, and the third piece is 1 inch more than 5 times the length of the first piece. Find the lengths of the pieces. Okay, so y'all, before we do that, let's do this. In all of these word problems, y'all, there's always going to be some kind of a comparison. Okay, so y'all, this is what I want to do real quick. We got Giovanna, we got Irania, and we got Nyla. Okay, so let's do this, y'all. Suppose I say Nyla, Irana, Giovanna. Okay, y'all, suppose I say, let me see. Let me come back one more time. Okay, so suppose I say Nyla. Okay, so guys, I'm going to talk about our ages right here. Suppose I tell you Nyla is 3 years older than Irania. Okay, so if I say Nyla, you're 3 years older than Irania, and Giovanna, you are 2 years younger than Irania. Y'all, if you notice, I'm talking about Nyla's age and Giovanna's age, but we're comparing it to Irania's, right? I don't know how old Irania is. So look, y'all, we're going to say her age is X. And if Nyla is 3 years older, doesn't that mean that her age is more? So this would be X plus 3. And if Giovanna, if she's 2 years younger, doesn't that mean her age is going to be less? And it would be X minus 2, right? And there's a comparison here. So y'all, the first 2 people we spoke about were Nyla and Giovanna. But when we talked about their ages, but we compared their ages to Irania. Whoever's age is being compared to, that's the one we're always going to call our X. And then we can kind of figure things out based from there. Okay. So y'all, the reason why I do this, I think dealing with age is kind of like an easier concept at first. So then y'all, when I scroll back to the problem that I have here, we're going to do this the same way. So look, y'all, we have 3 pieces. Okay. Right now, We have three pieces. Y'all, right now we're talking about the second piece, okay? But we're saying the second piece is twice as long as the first one. So y'all, this is what I'm going to do. I'm going to go like this. Piece one, piece two, piece three, okay? So I know I'm talking about the second piece, but we're saying it's twice as long as the first one. I don't know anything about the first one, y'all, so I'm going to call it X. If the second piece is twice as long, excuse me, y'all, that's going to be 2X. Then we get to the third piece, and it says it's 1 inch more than 5 times the length of the first piece. Well, 5 times the length of the first piece would be 5X plus another inch. Y'all, if you notice, they actually have that right here set up for us, right? Now, y'all, one thing I like about this problem, there's a picture. The picture kind of sets it up. Not every single problem is going to have a picture. So that's why I'm kind of doing this business here. Y'all, the other thing is the whole thing from the beginning to the end is 25 inches, okay? So what does that mean? That means that the first piece plus the second piece plus the third piece, it's got to add up to 25, okay? Look, y'all, let's draw a line right there, okay? X and 2X is 3X. 3 and 5 more, 8X. Okay. I'm going to go minus 1, y'all. So 25 minus 1 should be 24. And then when I divide by 8, y'all, right here, I'm coming up with X equals 3. Okay. But I'm not really finished yet, y'all, because even though I got X equals 3, the question is asking me, can we find the lengths of the pieces? So look, piece 1, piece 2, piece 3, right? Okay, let's do this. Look, y'all, piece 1 was X, and we got X to be 3. So the first piece is 3 inches. The second one, y'all, is twice that amount. Well, if this one is 3 inches, twice that amount, y'all, has to be 6 inches. Okay. The third one is 5 times whatever we got here. Well, 5 times 3 is 15. And then we're going to add one more, and that's going to be 16. So we found each of those three pieces, okay? So again, y'all, in these types of problems, if a picture is given to me, that's great. I love the problem when I got a picture. If I don't have a picture, then at least, we can always draw one, or we can kind of figure some things out, all right? All right. Let me go down to the next one here, y'all. And y'all, with this problem here, I usually think about this problem kind of like in a common sense approach. But let's read through the question. It says a car rental agency advertised renting a Buick Century for $24.95 a day at 29 cents a mile. If we can rent the car for 2 days, how many whole miles can we drive on a budget of $100? Okay, so let's take a look, y'all. Let's see what's going on here. The rental, $24.95, y'all, per day. We want the car 2 days. So guys, do y'all agree with me? $24.95 times 2, because we got to multiply that stuff out, times 2. Okay, so look, y'all, we're going to spend $49.90. Okay. Now, the second thing is they charge us 29 cents per mile. And we want to know how many miles can we drive. Okay. Well, let's think about it like this, y'all. Look, we have $100, right? Y'all, we're going to have to subtract off that amount, because that's how much we're going to pay just to get the car. So $100 minus $49.90. That's leaving me with $50.10. Okay. And that's how much money I have, y'all, to keep driving as many miles as we can. And for every mile, they charge us 29 cents. So what we want to do is we're going to set that equal to 0.29x. X is going to be my number of miles. And y'all, we're just going to divide. Okay. So right here, I'm going to take this, We're going to divide it by 0.29. And y'all, if you notice the number I'm coming up with, let me zoom in or pull this all the way up so you can see it. Let's go like this. Boom. Okay. What was it? 5010 divided by 0.29. Okay, so here we go, y'all. We're trying to figure out how many whole miles can we travel. Now, I know that we would normally say, look, if this is a 0.7, we should really round that up to 172. But, y'all, I don't actually have enough money to drive 173 miles. I can really only drive 172. Now, I know I'm closer to being able to drive that, excuse me, 173rd mile, but I honestly just don't have enough money, right? So we can really go 172 miles, okay? All right, y'all, for the next one that I have down here, again, I'm going to zoom in, y'all, and I'm going to see if we can figure out what is going on with this problem, okay? Look what it says, y'all. The president of a certain university makes 3 times as much money as the department head. Okay, so we got two people, y'all. We got the president and we have the department head. And we're talking about how much money the president makes, but we compare it to the department head. We're going to call that one X. And if the president makes 3 times the amount, y'all, that's going to be 3X. Okay. Now, over here, y'all, it says the total of their salaries. Remember what that means? That means the president's salary, which is 3X, plus the department head salary, which is X. That has to add up to 170,000. Okay. So look, y'all, we're going to go like this. 3X and another X is 4X equals 170,000. So when we divide everything by 4, 170,000 divided by 4, y'all, I'm coming up with 42,500. Okay, so 42,500. Now, I need to know what letter here, y'all, stands for X, right? Look, the department head. So the department head, y'all, makes 42,500. Now, remember, the president makes 3 times that amount, right? So look, y'all, I'm going to multiply it by 3. President makes 127,500. So y'all, I'm going to come back over here and I'm going to say, look, it looks like choice B. President is 127,500 and the department head is 42,500. So y'all, again, once I solved for X from here, the 42,500, remember it said the president makes 3 times that amount, right? So we took 42,500 and we multiplied it by 3, and that's how we got that number, right? Y'all, another thing we could have done was, remember what it said? It said that their salaries together was 170. Y'all, we could have done this too. 170,000 minus 42,500, and that would have told us whatever was left over, right? Okay. Let's take a look, y'all. Let's try the next one here. Let's see. 30 marbles are to be divided into 3 bags. So look, we're going to have 3 bags. So look, y'all, I'm going to call it bag 1, bag 2, bag 3. Okay. We're now talking about the second bag. 3 times as many marbles as the first. So I don't know how many the first one has, y'all. So I call it X. But the second one has 3 times 3X, right? The third bag, so bag 3, has twice as many as the first. So if this guy is X, y'all, that guy's got to be 2X. Okay. All right. How many marbles do we have total? We got a total of 30. Okay. So look, y'all, bag 1, X, plus bag 2, 3X, plus the third one, 2X, has to add up to 30. Okay. So look, y'all, 1 plus 3 is 4. 4 plus 2 more should be 6. So I got 6X equals 30. So I'm going to divide everything by 6. Boom, X equals 5. Okay. So again, y'all, I want to now think, okay, what does 5 stand for? Which one just had the X by itself? The first bag, right? So bag 1, y'all, it's got 5. Okay. Bag 2, 3 times 5. That's 15, right? And then y'all, bag 3, I'll write it over here because I'm running out of room. 2 times 5 is 10. So look, y'all, I'm looking for bag 1, 5, bag 2, 15, bag 3, 10. Okay, bag 1, 5, bag 2, 15, bag 3, 10. There we go. Looks like choice A is going to be the one that works for us, y'all. Excuse me. All right. Y'all, let me keep scrolling down here. And let's take a look what we got. International gymnastics. Okay, y'all, we got a few teams here. We have the U.S., we have China, and we have Romania. Okay. And look what it says. If the total number of the medals by each team are 3 consecutive integers, whose sum is 87. Okay. So, y'all, one thing I want to mention here, y'all, is what are consecutive integers? Okay, so let's do this on the side. Consecutive integers, y'all, are numbers like 8, 9, and 10. Consecutive integers, y'all, are numbers like 17, 18, and 19. Consecutive integers, y'all, are numbers like 23, 24, 25. Okay, that's what we mean by consecutive integers. All right, so look, let's take a look, y'all. The way I'm going to approach this problem, y'all, is I'm going to use my answer choices to see if we can figure out which was the right answer. Okay, US won more than China, so these guys beat China. And China beat more than Romania. Okay. So look, y'all, this has to be the biggest number. That's the second biggest. And this one here is the smallest. Okay. So let's take a look at the numbers and let's see, okay, which one has, like, are they in that setup, right? So is the US always the biggest one? So 89, 80. Yeah, that's kind of going in the right order. Same thing here, same thing here, same thing here. Okay, so that doesn't help me too much. What's the other thing we need to know? Oh, look, y'all. Oops, sorry. Look, y'all. The other thing is the sum of those numbers, y'all, has to add up to 87. Well, look at those numbers. They don't add up to 87. Those numbers are big, right? So I already know, y'all, that A is not the right answer. Okay. Y'all, what I'm going to do now is I'm going to see